Alright, so this is numero dos on the projectile motion section. We've got a 100 meter per second projectile at a 60-degree angle. What we first have to do on these is we need to realize that there is a velocity in the x and a velocity in the y. So we need to realize that, and we need to break it up into the components first. So we need to do Vx equals 100 cosine 60 and Vy equals 100 sine 60. So if we plug these in, we should Vx equals 50 and Vy equals 86.6. Now it's critical that we break these up first. We can't do anything until we break it up. So the first question says how high will the cannonball go, which is dy. So this is our first problem, and our second one is how far from the launch site will the cannonball hit. So the second thing is dx. So we want to know what's the dy and what's the dx. Okay, so let's take a closer look at the path this ball will travel. So here we go. Here's the ground. All right, the ball or the cannonball will come out and do like this. All right. At this point right here, we know that the height is the greatest. So this is where we're going to try to find the height. So height equals question mark at this point. We also know that the time here is the time to the top. We also don't know that information. One of the nice things we can do here, though, is say that the that the velocity in the y is equal to 0 at this point. All right, that can be convenient. Why is that convenient? Well, to solve this problem, we clearly need a time to the top, because if we are trying to find height, that's distance in the y equals 1/2 ay t squared plus viyt, and we don't have t, so we need to find t. So what does this have anything to do with it? Why does that help us out? Well, we can say that the initial velocity here in the y direction is 86.6 meters per second. We can then say that the final velocity in the y here is 0 meters per second. And does this allow us to solve for time easier? The answer is yes, because we can use our acceleration of the y equals the final velocity in the y minus the initial velocity in the y divided by t. Okay, in this case, the initial velocity in the y is not 0 because it's initially going up. So we do negative 10 equals 0 minus 86.6 and divide that by t, and t, if you solve for this, equals 8.66 seconds. But this doesn't give us our answer because we need to know how high the cannonball goes. Well, now we have a time to the top, though. So this is time to the top, and we're going to plug that in over here. Okay, so let me bring a new page in. So we're going to use dy equals 1/2 ay t squared plus viyt. So the question here is, what is the initial velocity in the y in this case? In this case, it's not 0, right? It's 86.6 times 8.66 seconds, and then plus 1/2 times negative 10 times 8.66 squared. And so if we do this, we should get 374.9 meters. Okay, so that gets us our distance in the y. That's our height. Yay, we solved for the height. Okay, so we've got the height. Now, I've got to figure out the distance in the x. We know from back here that, by the way, 375 meters. All right, we know that the velocity in the x is 50 meters, and we know that the formula for the distance in the x, the only formula we can use is Vx equals dx over t. So it's convenient to know this is 50 meters. But is the time we used the same as the time that we used here, the time to the top? Well, the answer to that is no. We don't use the time to the top. Because if we look at this drawing, the time to the top stopped right here. But what we need is the distance to, what we need is the distance, or the time from here to here. So we need the time total. Well, how much longer does it take to get from here to here compared to here to here? Well, it takes double. So the time to the top times 2 equals the time in the air. And we need to use the time in the air here. So this is the time in the air. So we know that it's 50 meters per second, and we know the time in the air, or the time to the top, was 8.66. So the time in the air then has to be equal to 8.66 times 2, which is 17.3. So it's in the air for 17.3 seconds. So erase that and put in 17.3 down here. 17.3 times 50 is 865 meters, and so that is the distance in the x. So you've solved now for the distance in the x. How far from the launch site will the cannonball hit the ground? Well, it'll hit 865 meters away. And how high will it go? It will go 375 meters into the air. Okay? So there we go. That was question number 2.